Okay, I was reducing a matrix over here. It got bunched up here, so it's just as well that the battery on my camera died somewhere in the process. Now I have to start the video over. I'm not going to erase any of this. I'm just going to do this over here. There's plenty of room. So we have the matrix A equals 2, 4, 3, -2, and we want to invert. Now we already know a way to invert a 2 by 2 matrix, but it doesn't work for matrix of any other size. Okay, remember, to invert a 2 by 2 matrix, we find the determinant. -4 minus 12 is -16. We reverse these numbers, we make these numbers negative, and we divide by -16, and we get the inverse matrix. Again, that doesn't work. There's nothing like that for a matrix any bigger than 2 by 2. 3 by 3, 4 by 4, you can't do it. So you have this method of inverting, and it's the most efficient method of inverting a matrix. And the method is this. You form the matrix A augmented by the identity matrix. Now you do this for any dimension. The identity matrix has to have the same dimension as A, and of course A has to be a square matrix or you can't invert it. So our matrix will be, our augmented matrix will be this. And now we want to reduce this matrix. We want to reduce the matrix to the form I augmented by B, where I is the identity matrix. In other words, we want to do the row operations that reduce this matrix here, the 2, 4, 3, -2 matrix, to the identity. Whatever we end up with on the other side is our inverse matrix. At least that's the claim. Now it's so, and we're going to see why it's so. But right now, let's just do it. So when we get down to our last step, remember we're going to have 1, 0, 0, 1, that's our identity matrix. And then we're going to have 4 numbers here, whatever numbers follow from the reduction process. Okay, so first thing we want to do is we want to get a 1 here, don't we? Remember, we're going to get a 1 here, then a 0 here, then a 1 here, and a 0 here. That's our process for a 2 by 2 matrix. Okay, how do you get a 1 here? By valid operation? Well, you take 1/2 of everything in the first row. That's going to give you 1, 2, 1/2, 0. Now, I'm assuming you know how to do row reduction. And if you don't, that you're going to review it and practice it a lot so that next week you will know it. Because some people don't seem to be very up on the idea of row reduction. Okay, anyhow, that's what we get. So we multiply the first row by 1/2, that's all we do, we get them. Second row is unchanged. Then we've got our 1 here, we want to get a 0 here. Well, if we've got a 1 here, then we've got the rest of this row, because we can't change that 1 without somehow changing the rest of the row. But we want to get a 0 here. How do we do that? Well, we take -3 times this and add to this, we're clearly going to get 0. So we take -3 times the entire first row added to the second row, and that'll be our second row. So -3 times -2 is -8, add -2, we get, what did I say? So -3 times 2 is -6, added to -2 gives us -8. And then over here, what do we have? Well, -3 times 1/2 is -3/2. Added to 0 gives us -3/2. -3 times 0 is 0, added to 1 leaves us 0. Next step. We've got the 1 here, we've got the 0 here. We don't want those to change, but we want to get a 1 here. Now, if we got 1 here, then we have to have the rest of the first row. Again, there's no way to change that. How do we get a 1 here? We divide by -8 or multiply by -1/8. Well, -1/8 of -8 is 1. -1/8 of -3/2 gives us +3 over 16. And negative 1/8 times 1 gives us negative 1/8. Okay? Now, the next step takes us here, because in the next step we want to get a 0 here, so I left myself more room than I needed to, but that's okay. So my second row is already locked in. I've already got my 0, 1 here, so I've got that part of the identity. So I've still got my 3/16 and my negative 1/8 here. So that row's the same as it was, but I'm going to then multiply negative 2 times every number in this row and add to the first row to get my 1, 0 here. Negative 2 times 1 is negative 2 added to 2 is going to give me my 0. Okay, well, negative 2 times 0 is 0 added to 1, we still got 1. Negative 2 times 1 is negative 2 added to 2 gives me 0. Negative 2 times 3/16 is negative 3/8. And 1/2 is 4/8. Negative 3/8 and 4/8 gives me 1/8. And then negative 2 times negative 1/8 is positive 1/4. And that's what I have. Okay, so this is my B matrix. So I say that B is 1/8, 1/4, 3/16, negative 1/8. Now we're asked to verify that B and A are inverses. Well, very easy. A times B is 2, 4, 3, negative 2, multiplied by 1/8, 1/4, 3/16, negative 1/8. And what's that equal? That equals the identity matrix, and I'll let you do the multiplication, but it's very simple. So you should easily be able to multiply this matrix by this and verify that it's the identity. So A and B are inverses. Okay. Now somehow the video that I did on this didn't show up, so I had to redo it, but that's just as well because you got to watch me write it out. And then the next clip will refer back to this, but all this will be over here and maybe look a little better than what you've got over here. So in the next clip, you're going to see just exactly this, but then things will move on from there.